Hi everyone, how are you? Again, we back to you upon request of one of the students. He wants us to explain how we can find the current and the voltage in each resistor in a simple circuit, simple DC circuit. Okay, again, if you have any question, you can contact us at this phone or Gmail. Let us start. We have the circuit ready here. We have this circuit. We have supply here, or supply is 250 volt, 250 volt comes from this. The current in the parallel here goes from the negative side to the positive side, the power supply here, and goes here. Let me choose the green color, distinguish. Will go I here, I here. At this junction point, the I will goes to two current, I1 and I2. I1 and I2. Let me just change take two different colors. This, okay, blue, no. Okay, let me choose this color. This I2 and here I1. Okay. Then I2, when he comes to here, I'm gonna call it I2. When it comes to this point, it becomes here again I A, and here I B, You see, again, they meet together at this point and they come back to be I2. Now I1 goes here, keep going here, I1 till this point, I1. Then we have A and B. Here we're gonna have IC and ID. Then ID here. Then ID end up here. ID, IC here. IC here. Then IC goes here. IC becomes I1 because I1, the IC and the ID, they come from I1. Then this guy becomes I1 again. I1. Okay, I'm trying to get the same color, yes. I1. Look here, this I2 here and I1 here, they met together, then go back to be I, which is our main color. And then the color the current keep moving up and down. Again, I goes to I1 and I2, I2, IA, IB at this, IA and IB back and back to be I2. Then they end up here I2, I1, ICID, ICID, going to meet again here, again at this point. Then I. My objective is to find I1, I2, that's what I want to find. Then at the end, I need to know, make this table, small table here. Let me just fix this guy here, make it smaller. R6. $160. Oh, and I'm gonna make my table here. I'm gonna show you what I mean by my table. Small thing will help you guys. Okay. One, two. One, two, three, four. I will let you finish. I'm gonna let you see what I'm gonna do with this table. One, two. Each resistor has current and voltage. Look what we're gonna do now. 1, 2, 3, 4. We need 7 for each resistor. 5. Okay. R1. This 1, 2, 3, 4, 5, 6, 7. R1, how much? R1? $50. R-I-V. R 50, R2 100, R3, this 100 again, small, this 100. Organize yourself, we'll see it easy. R2, R1, R2, R3, R4 20, R5 160, 160, R7 is 50. He give me the color of which guy? He give me the current of this guy, R7, which is 1.25. Now remember V equal IR from Ohm's law. And when I find the I and I have the R, everything is simple. First step, I have to simplify the circle to find the main current. R2, R3 parallel, which is the equivalent will be 1 over R, 1 over 100 plus 1 over 100. We have 100 denominator, 1 plus 1, 2 over 100, which is R equal 100 equivalent for these two, for 1 and 2 over 2, which is 50 ohm. The same we're going to do for these two guys. The same for these two guys, 5 and 6. 5 and 6. 5 and 6. 1 over R equivalent 1 over 160 plus 1 over 160 equal 2 over 160, 1 over R. Just flip it, flip both sides. This gives you R equivalent equal 80. Now this guy, R equivalent, you see this guy, 5 and 6. 5 and 6, the equivalent to 5 and 6 is in series with R4, which is 20. Then 5 and 6 together combine with R4 in series, which is mean this guy 80 plus 20, which is 100. I can tell you how my circuit would be. I'm going to simplify my circuit to be like this. This small, yeah, to see what I mean. To show you what I mean. You will see what I mean here. Okay, here we found this 100, the equivalent for the last part. This 100, and this is 100, and this is 50. R7, this is still R7, which is 50. And this is this guy, which is R1, which is 50. 50. Okay. Now, these two, this and this, in parallel series, right? Which is 150. Okay, then I'm gonna break it down. This is quick, you add them up in series. 150, 100, and this is 50. Now, these two parallel, 1 over 150 plus 100, 1 over 100. One over R, which is the common denominator is 300. The common denominator for these two guys is 300. 150 is twice, and this 3 times. 1 over R, which is 1 over R equal 5 over 300. Flip both sides. R equal 300 over 5 equal 60 ohm. Then, my final circuit, which is the easy one, I'm gonna leave it in red. I have two, I don't have to do them, but in what? This guy, 60, and this guy is what? 50. And this is 250. Now I can find the main current. Then I'm gonna go backward. V equal I E, which is the electromotive force. We call this electromotive force. Electromotive force, where the power supply, which is the power supply. V equal IR, I'm sorry, I'm going to change it to make it what? There. Equal IR. Okay. R here for these two is 110 in parallel series, right? 110 ohm. Remember this. And from this I total equal E over what? I, which is 250 over 110, which is 25 over 11 ampere. 25 over 11 equal about 2.27 ampere. 2.27 ampere. Okay. Then let us back to, this is goes in this 227. 227 ampere go to R1. R1 has 2.27 ampere. Good. I2. Here's the idea. I need you to watch. I'm gonna go to the here. I'm gonna move my board here. I2. Just what I need you to listen to what I'm saying. How we find the branch currents. I2. You make a denominator and numerator. I2 goes from where? Come from where? I2 goes only to these two guys, R2 and R3, right? Look, you see the I2? To understand, I2 come here and distribute between this and this, right? Good. Which is the equivalent of R2 and R3. The equivalent of R2 and R3, the equivalent of, because why we choose this one? This always, when we're looking for a branch current, in the denominator we put where the branch current goes to only I2 and 3 and end up, right? A and B. Then let us find I2, which is actually 1.25, but I'm going to prove it for you. Okay, I2 all the way, start from here, all the way, I2 comes here and end up at this point. Okay, which is R2 and R3 R1, we find it 50 plus 50, 100, right? Here, if you go back, little bit, 100, R2 and R3, I have to do it over here. R2, oh here, I have to pick this guy here. R2 and R3 is 100, 100, 2 over 100, 50. 50, here 50, 50, 50, 50. I have to fix something here. Just small fixing here. Half number. And this. $100. And this is 50. Because here 100 100 and here 1 over R 2 over 100 flip it R equals 50. Then this guy will be 100 and then this guy will be 100, and that's a lot easier. Small, this with this, 25, 2.5 ampere. Okay. Okay. Which is true, look here. If you look at this circle, I have, if you look here, I have, if you look, the current, I'm going to show you here. I know the current here, 2.5. And he gave me this guy here, 1.25. Since I have the same resistor here and there, it's going to be 1.25 ampere again. I'm going to prove it for you there. Okay. And then it goes to 100. Why 100? Go back. Go to these resistors. Go here. 50 and 50, the I2, the I2 here, go to 50 and 50, here 50 and here 50, good. And I1 goes what? You see the main current is go to which one? Here we have 100 and here we have 100, right? Which is, right? We have 50, right? That now in the bottom we said, I'm gonna write it. This guy here, where I2 goes, which is the resistors. The I2 comes from where? Come from I, which is how much I? 2.5. And I goes to these two, I goes to here and here only. I distribute between 50 and what? 100 and 100, which is 50. Which is 50. Okay. Multiply 1. Multiply this by this. 125 over 100. 1.25 amperes. Good. This I2. Now, but we know I equal I1, right? Plus I2. And we know this guy 2.5. And we know I1, what I need I1 and I2. And I2 1.25. Solve for this minus 1.25 minus 1.25. This cancel 1.25 for I1. Now let us go to our resistors. I1 goes to R4. Then in R4, this is 2.5 we said, right? R4 has the same as I1, which is 1.25. And 50 have the same, right? Now I need to find A and B. Look A and B to understand. IA came from where? Came from I2, right? And IA goes to where? Only to, look, IA goes only to this 100. To the 100, right? To the 100 only. Resistor, right? Only. I2 goes to which resistors? I2 go to 100, and the 100, which is 50, plus 50 is 100. Which is, right? 50 is back to the 100 and 100, the 100 ohm and the 100 ohm. I'm gonna to the 100 and 100 ohm, the one here. I2 and A. This give you 50 only, right? And we know I2 2.5 times 50 over I2 is 1.25. I 1.25 over 100. If you use your calculator, this is going to be 0.6125, I think so. 1.25 divided by 2, 0.625 ampere. Since IA the resistors for A and the resistor for B the same, 100, 100, then we have the same exact current, 100, 100, 100, 100, which is 1.25 for which resistors? Let me just make sure from my resistance, which is 2 and 3. 2 and 3, 1.6. I like green. I'm gonna use the green. I'm gonna use the green. 0.625. .625. Now, the 160 and 160. We have I2, right? Since the same thing, I1, ID, and IC. Look, to understand more, I'm going to do it this one. ID, and IC. ID come from I1, goes to 160 and 60, which is 80, the 160 over I1. How much I1? ID come from I1. I1. I went to the 3 to ID to 160, right? ID, the resistors, where ID goes. You see, ID come from I1. ID come from I1. Comes from this guy, and I1 goes to these two, 160, 160, which is 80, and ID goes to 160 ohm. If we find ID is the same as IC because we have the same resistor. If you notice something here, which is 1.25, and this one and this 2 divided by 2, which is the same as ampere. The last step is easy step and not hard. 0.625. All what you have to do to fill the last column, which is the A, or call it anything, AVE 0.625, 0.625. V or E, the same. Equal what? I. Multiply. Here, 5125 volt. Here, 62.5. 62.5. Watch something. If you add these two, is 125. Add this to 50. Why? Because the voltage across this point, and this point is 250, right? And we have how much here for the 2 and 3, 125, right? And this the same here, right? Good. Because we have some voltage here. With the voltage here, 50 times 2.5, 125. 125 here, volt, because 50 times 125 and 60, and this one, multiply this by this, add them, 250. Go here, R4, which is how much we have, multiply this by this, 20, 45 volt, and this 160 times 160, 100, and here 100, and this 57, which is 75. Okay, that all what we have for the day. Remember, if you need any help, contact us as this our address. This is our Gmail address, and have a nice evening.